Yes. Hello students, welcome back to the class. Last class we discussed about failures of classical free electron theory. Now today we are discussing about success of quantum free electron theory. So you know that the failures of classical theory, there we discussed mainly three cases. So one is specific heat at constant volume, second one is temperature dependence, and the last one electron concentration. So here also that failures only explained by this quantum theory as a success. So first case we are discussing as a specific heat, second case temperature dependence of electrical conductivity, and the last one dependence of electrical conductivity on electron concentration. So first we should know the electrical conductivity expression that is given by the quantum free electron theory. You know the expression for electrical conductivity which is given by the classical free electron theory, it was sigma is equal to ne square tau divided by m, where n is the electron concentration, E is the charge, tau is the mean collision time, and m is the mass. But here they have changed the electrical conductivity expression from the quantum theory, that is sigma is equal to ne square lambda divided by m into Vf, where m is actually m star, it is a active mass or it is a collective mass, we can call it as it is different from the rest mass of the electron, that is a effective mass. It is also called as a effective mass. It is different from the rest mass of the electron, because rest mass of the electron, how it is different from effective mass means, electron not only possess, whenever it is in electric field, it possesses extra mass compared to the rest mass of the electron. Whenever it is in the normal state without the influence of any electric field, it possesses a normal rest mass, but whenever it is in the influence of some other electric field, the mass will be different. That is what explained by the quantum theory. See here, sigma, once again it is depending on the electron concentration, directly proportional is the charge of the electron. Here lambda represent the mean free path and Vf represent the Fermi velocity. So they are giving here two terms, that is two additional terms here. Instead of mean collision time, they have given the mean free path and as well as the Fermi velocity. This is the expression given by the quantum free electron theory. Now first we will go for the first case, that is specific heat. See here is the specific heat. The expression given by the quantum free electron theory, that is specific heat at constant volume, that expression is equal to 2k divided by EF. So according to them, see here, according to free electron theory, quantum free electron theory, it is only those electrons which are energy below, just below the Fermi level, can absorb the heat energy, and hence a very small percentage of conduction electrons are capable of receiving energy. You know, Fermi energy means it is the highest occupied level at the absolute 0 Kelvin temperature. So below which all the energy levels are completely filled, and above which all the energy levels are completely empty. So it is just below the Fermi level, how many electrons are there? Only those electrons will absorb the energy. Means only a small percentage of conduction electrons, which are only outermost electrons, will conduct. Those electrons will absorb the heat energy. So the value of specific heat will be very small. That is explained by the quantum theory. See here, according to them, they have given the expression specific heat at constant volume C is equal to 2K divided by EF into R into T. You know, K represents the Boltzmann constant and EF represents the Fermi energy. So they are actually including the Fermi energy here. Specific heat is mainly depending on the Fermi energy, and R is the universal gas constant and T is the temperature. So from classical theory, you know that specific heat is Cv is equal to 3 by 2 into R, but they have shown the temperature dependence is not there for the specific heat, so they have failed. So here they are giving the expression directly like this, 2k by EF into R into T. So it is depending on the universal gas constant and as well as T. And if you compare this value with the experimental value, look at here, the experimentally we are getting the specific heat at constant volume, that CV is equal to 10 power minus 4 into R into T. Look at here, R and R both are same and it is matching here. Temperature term and temperature term both are matching here, and we will go for the constant value 10 power minus 4 small value. Is it matching? So to do this we have to go for the constant values. 2 is a constant, K is a Boltzmann constant. You need to substitute this 1.38 into 10 power minus 23 as a Boltzmann constant. See, Fermi energy we are taking for a typical value 5 electron volt. Why means, metals Fermi energy varies between 1 electron to 10 electron volt. So on an average we are taking 5 electron volt. We are substituting this Fermi energy 5 electron volt. Convert this electron volt into joules and substitute it. So 5 into 1.6 into 10 power minus 19. If you substitute it both 2K and EF, you will get 10 power minus 4 only. So it is exactly matching with the experimental value. So this 2K by EF value is giving 10 power minus 4 R into T. It is exactly matching with the experimental value. Hence, the quantum theory successfully explained the concept of specific heat at constant volume. Okay. Now go for the second one, that is temperature dependence of electrical conductivity. So you look at the expression for the quantum free electron theory. The sigma is equal to Na square lambda divided by m star into Vf. It is, see here I written m represent the effective mass. See, as per the quantum free electron theory, the scattering of free electrons in a metals is due to the vibrating of lattice ions. Whenever the free electrons are moving in their path, it is disturbed by lattice ions. Lattice ions means the positive ion cores. Whenever the electrons are removed from the atom, the nucleus will become a positive ion core. So it is act like a positive charge carrier whenever the electron is removed from the atom. Okay. Now these positive ions are very sensitive to temperature. So whenever the heat is increased, suppose you are supplying the heat to the metal, so that metals will receive the thermal energy. These positive ions are start to vibrate about a mean position. Okay, so these vibrations will disturb the movement of electrons, so that as the temperature increases, the resistivity of a metal goes on increases. So that is the main concept here. So that is what we have explained here. See, scattering of free electrons in metals is due to vibrating of lattice ions, and the vibrations occurs in such a way that the displacement of ions takes place equally in all directions. Means our vibrations ಏನಾಗ್ತಾ ಇರುತ್ತೆ metals ಅಲ್ಲಿ, it is like equal in all directions. Means it is tracing a path like a circle. On the circular path ಅಲ್ಲಿ ಇದನ್ನ means that path will be like a circle. Okay, if R is the amplitude of vibrations, so we can imagine that the path of the electron blocked by the circular cross-sectional area by R square. Means you just consider that R is the radius of that circle, whatever it is tracing like a area, that is a circular path. If you imagine small r is the radius of that circle, and pi r square represent the area covered by that circle. Atom ಏನು ವೈಬ್ರೇಟ್ ಆಗ್ತಾ ಇದೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ, ಆ ಏರಿಯಾನ ನಾವು ಯಾವ ತರ ತಗೊಂತಾ ಇದೀವಿ ಅಂದ್ರೆ pi r square ಅಂತ ತಗೊಂತಾ ಇದೀವಿ. Y means R represent the radius of that circle. Okay, you know the radius of the circle is pi r square. So this atom is blocked the movement of the electrons in the circular path. Electron move ಆಗ್ತಾ ಇರೋ ಒಂದು path ನ disturb ಮಾಡ್ತಿರೋದು ಏನಂದ್ರೆ this positive ion. That positive ion, as the temperature increases, this vibration goes on increases, and it is covering more and more area, circular area. So that's why the mean free path will be reduced. You know, mean free path means it is the successive distance between the two successive collisions. Means average distance between the two successive collisions between electron and a positive ion. So ಏನಾಗುತ್ತೆ, electron path decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಈ vibrations ಜಾಸ್ತಿ ಆದಷ್ಟು. So that's why this mean free path is inversely proportional to area blocked by the free electrons. Area blocked by the positive ion cores. Okay, so that's why mean free path is inversely proportional to 1 by pi r square. So you know that amplitude of vibration is directly proportional to temperature. Why? As the temperature increases, the vibrations also goes on increases, so that radius also goes on increases. So if r square is directly proportional to temperature, so lambda is inversely proportional to temperature. You know, lambda is mean free path is inversely proportional to temperature. And look at the expression for sigma, that is electrical conductivity. It is directly proportional to lambda, means we can write lambda is inversely proportional to temperature, means sigma is inversely proportional to temperature. Got it? So the experimental value also same. The sigma is inversely proportional to temperature. So it is exactly matching with the experimental value. Got it? So quantum theory successfully explained the concept of electrical conductivity, that is dependence of temperature on electrical conductivity. Now go for the last one, dependence of electrical conductivity on electron concentration. You know that according to the both the cases, that is classical free electron theory and quantum free electron theory, both the cases sigma is directly proportional to n. As the number of electrons increases, free electrons, sigma also should increase. But here they have not only given the n, they have given some other parameters. So according to the quantum free electron theory, as n increases, sigma should also increase, but they have given the extra term lambda by Vf and as well as m. See, read this one. From the above expression, it is clear that electrical conductivity sigma depends on electron concentration n and ratio lambda by Vf. You know, lambda is the mean free path and Vf is the Fermi mass. It is mainly depending on this term. And look at here, the value of lambda by Vf is found to be 3 times greater than the monovalent compared to the trivalent or divalent atom. You know, divalent and trivalent metals are showing less conductivity compared to the monovalent. Last class I given the examples related to this monovalent, bivalent and trivalent metals. Okay, see, compared to the trivalent and divalent metals, monovalent are giving the greater conductivity. Okay, see, y means lambda by Vf ratio is 3 times greater than this bivalent and trivalent metals. Okay, see, that's why ಈ lambda by Vf ratio ಏನಿದೆ ಇದು 3 times ಜಾಸ್ತಿ ಇರುತ್ತೆ ಯಾವುದಕ್ಕೆ ಡೈವೆಲೆಂಟ್ ಮತ್ತೆ ಟ್ರೈವೆಲೆಂಟ್ ಕಂಪೇರ್ ಮಾಡಿ, so that the total value increases the conductivity. Okay, not only this term, go for the effective mass. See, effective mass of the divalent and trivalent metals have more than the effective mass of the monovalent atoms. Illi m effective mass is inversely proportional to conductivity. As m increases, conductivity should decrease. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಟ್ರೈವೇಲೆಂಟ್ ಮತ್ತು ಡೈವೇಲೆಂಟ್ ಮೆಟಲ್ಸ್ ಏನಿದೆ ಅದರಲ್ಲಿ ಮಾಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಕಂಪೇರ್ ಟು ದ monovalent. Hence conductivity decreases. Got it? So not only this ratio, even m also plays a very important role. So hence successfully explained the concept of electron concentration. So here they have introduced the parameters lambda by Vf and as well as effective mass. So in this way, quantum theory successfully explained all the three concepts, that is specific heat at constant volume, temperature dependence of electrical conductivity, and as well as the last one, dependence of electrical conductivity on electron concentration. I hope you understood. Thank you. Thank you very much.